Guys, welcome back to my channel. Again, this is John with a video series on how we turn this trash, dry leaves, cartons, plastic of all sorts, wood chips, even tires, and all this trash into variable crude oil. I also explained that after the process of pyrolysis, what you're left behind with is black carbon and steel scraps from either tires or whatever you have used to make your crude oil and crude oil. Now in this video, I will explain now the next step of processing the crude oil into something usable. So after using all these materials, you get crude oil that contains so many impurities. One of them is water. Water is not good in a combustion engine since it causes corrosion, and you don't want that. So now this crude, there contains all that. So what is the composition of this crude? It contains diesel, kerosene, free fatty acids, water, some complex molecules formed from either silicon if the trash was not so clean. So it has so many impurities. So now how you separate those impurities to form a cleaner crude is what I'm going to explain in this video. Okay, now what most of the petroleum companies use is something called a demulsifier. What a demulsifier basically does is that it helps separate the oil. For example, I can show you right here. This, I don't know if the lighting is so good, but maybe I can use lighting from the sun. This is water and oil. For this separation to occur, then you have to have a demulsifier. And since a demulsifier is not easily acquirable, so what did I do to solve that problem? That's where I decided to go with the production of gasoline. I in fact have some sample here. It's very, very clean, but we'll get to that later. So now, like I said, this crude oil contains what? Diesel, kerosene, wax, tar, even tar. All those heavy molecules in it, which are not mostly petroleum. So now what do I do to get more petrol from it? What process do I use to get more petrol from this? The process itself is called hydrocracking. In hydrocracking, what you basically do is that you take these long chains and crack them under a catalyst and heat to reduce the chain size to this now. Now this is upgraded crude. The same crude as this one, but contains a higher percentage of the lighter molecules. Why specifically did I do that? Because in the lighter molecules have so small, you can call them intermolecular spaces in between them. Hence, they do not easily dissolve some of these impurities. So what happens is that after the upgrading of the crude oil, you get it to separate by itself. The same way I've showed you the separation of oil and water. So that's an added advantage of upgrading crude. The same process also increases the octane. Increases the octane level of the gasoline you produce from the crude. And guys, don't forget that we actually acquired this crude from trash. So this is kind of very amazing that the same processes we use in the processing of crude that we mine from the ground is the same. You treat this crude the same way because in fact it is the same. So now, how do I really upgrade this? On what machine did I use? Beside me here, you will see some huge containers. They are actually very heavy because inside them is a catalyst. A catalyst that I didn't really develop it, but I had to research very, very intensively for me to get the chemical composition of that catalyst. So now, what happens is this. You get crude oil through this pipe. Goes down through this pipe here, and actually in the crude oil is actually in vapor form. So you evaporate the crude oil first. While this thing is still in fire, so this thing is still under very high heat. It's being heated. So this vapor, this crude vapor, will go down through this pipe and then pass through the hot catalyst. While doing that, it gets cracked, and the catalyst actually also the catalyst doesn't get used up, but what happens is that the catalyst active sites get clogged up by free carbon. So now these vapors of crude oil pass through these catalytic chambers, get cracked to form now this upgraded crude oil. And I'll show you what is the main difference between them. So this is the machine that I used. It's called a hydro cracking machine. In it contains catalyst, which gets heated together with the crude to form now the cracked crude. Now let me show you the major difference between them. The major difference between them up front should be that this contains the less evaporating molecules, the less volatile molecules than this. And how do you test for that? If the camera could come closer, you'll see this well demonstrated. This is crude oil that has not been processed yet. So in it, it should contain vapors of any flammable liquid that is in it. So if I light this match on top of this cup and actually push, you see, yes, the flame does get bigger, but there is no self-sustaining flame. So that means it contains a very less amount of the high volatile part of the hydrocarbon chains. Now, this is the crude oil that has been upgraded. And if I do light a match on top of this cup, which is not advisable, so please guys, don't try this at home. Don't try this at home. I'm just doing this because I've been doing it for a very long time now. If I count my math right, it's actually been a year or something like that. So now, what happens when I light this match on top of this cup and also squeeze it? Look at that. It contains vapors of the high flammable, high volatile hydrocarbons in it. So, and that's how you upgrade. That's how you upgrade this crude oil into this, containing a very high volume of the high flammable gases, high flammable molecules, which helps in the separation of water and crude oil. And in the next video now, I'm going to explain to you now how you take this crude oil, which have been upgraded, to finally make this clean, good old clean petrol. And I'm actually going to show you the flash point of it. So stick around and don't forget to like, subscribe, and comment if in case you